Okay, so let's continue with the question. So we already did part A, B, C. Now we are on part D, the total distance covered. So I was saying to be able to find the total distance covered in a distance velocity area down. So the first area I want to find is the area of this trapezium here. We are saying area of a trapezium is given by half A plus B multiplied by H. So this is going to be half. The A in this case is from here up to here. We can see we're moving from 4 up to 10, so that is 6. Just say fine, which is 10 minus 4. And then the B is from here up to here. So you can see from 0 to 10, that is a 10. The height is this distance from the down to the top there. We can see that's a 20. So I can just say 2 into 20, that's 10. 6 plus 10, that's 16. So this is 16. And then 16 times that 10, that is going to give us 160 meters. So this is the first distance. And then we also have this region which is here. This is also a trapezium. It's just that we flipped it. This is a trapezium, but it's looking like this. So in this case, this distance here is 30. This distance here is 20. And then the distance down from 10 to 15, this is 5. Like you say 15 minus 10. The ones I'm saying, we have got this distance which is 20, and then this distance which is 30. Is this okay? Can you follow up that one? Okay. So the area therefore is going to be given by half A plus B. So in this case the A is this one, which is 20, and then plus the 30, which is the B, and then the height is going to be this region, because you always take it, you are going to arrange it like this. So always these two parts which are parallel, that's the A and the B, and then the height, that is going to be the 5. So this is going to give 20 plus 30, that is a 50. So that 50 we are going to divide it by 2, that is going to be a 25, and then 25 times 5. So first 5 times 5 is 25, 5 remainder 2, 5 times 2, that's a 10 plus 2, that's 125. So that would be 125 meters. So we have found also the area of another region here. And then the next, this is also a trapezium, so we also find the area of this region. If you want, you can take it as a rectangle and a triangle. So the area of that trapezium is also given by half the A, this region from here up to here, from 15 to 18, that is a 3, plus B, we are moving from 15 up to 28. So if we get to subtract, that is going to give us a 13. And then the height H from the bottom to the very top there, that is going to give us a 30. So this is going to give us 3 plus 13, that is going to be 16, times these two can go into 30 15 times. So what we have is 16 multiplied by 15. 5 times 6, 30, 0 remainder 3. 5 times 1, 5 plus a 3, 8. And then we have got 6, 1. This is 0. This is going to be 4 remainder 1. So that is going to be 240. So now to find the total distance which is been moved, we need to add these 3. So therefore, distance, now we use S. Distance is 160 plus 125, then plus 240. And this is going to give us 160 plus 125 plus 140, that will be 525 meters. This is the total distance that was covered. After finding the total distance, we need to find also now the next question, the average speed for the whole journey. The average speed for the whole journey, speed is given by distance over time. So the total distance which was covered was 525. The time we took, we can see that the time took 28 seconds. So this is going to give us 18.75 meters per second. So that is going to be it. And that's how we get to work out this question. Okay, let's look at some others. We have got also this one. The diagram below shows the speed time graph. In which region is acceleration decreasing? So as we said, when you're talking about decreasing acceleration, you need to look at a region where you've got a line either looking like this or looking like this or like this. As long as the line is more going more like in this region, it's making more like a circle in that direction, that's a reducing or deceleration. So at this point here, so let's see what we've been given from V to W. V to W, the line is looking like this, so that's not decreasing, so this can't be the answer. And then from W to X, we can see the line is looking like this, so this is okay. From X to Y, this line here, this can't be it. Then from Y to Z, okay, Y to Z, this line is looking like this, so this is constant deceleration, not acceleration is decreasing. No, it's constant deceleration. For example, if we are decelerating at 5 meters per second, we'll continue decelerating at that rate. But when you see a line like this or a line like this, it means when you are decelerating at maybe 5, you are going to start decelerating at what? At 3, at 2, and you also start to decelerate at 0. So the answer is B there. Okay. So let's consider this one. The graph below shows the speed time graph of an athlete. So the question was find the total distance covered. So to be able to work out the total distance, we need first to find the area under this graph. So I'll first work out this one up to this point because that's a trapezium. So area is given by half a plus b multiplied by the height. So this is going to be half the a. In this case, the a is the region on top there, so it is from 4 up to 14. So 14 minus 4, that is a 10, and then plus the b is from 0 up to 14. Then the height is this region from 0 up to 5, so that is 5. So at 10 plus 14, it is going to be 24. And then we have got over to this 2 which is here, and then plus a 5 which is, times a 5 because this 5 is going to be multiplying. So 2 into 24, that is a 12. So I've got 12 multiplied by 5, which is a 60. And then the next one, we also determine now the area of this other trapezium, this small trapezium which is here. I'll write it here. So we have got from 14 to 16, this is going to be 2. And then we have got from the very bottom here to the very top, that is 10. And then we have got now also here from the bottom to 5, so this is 5. So the area is going to be half a, those two parallel lines which move like this, that will give you a and b. So we have got 5 plus 10, and then multiply by the height which is going to be 2. So these two are going to cancel out. 5 plus 10 is a 15. So just add to find the total distance covered by the athlete. That is going to be 60 plus 15. That is going to be 75 in this case. Let's consider this one. Which of the following diagram shows an athlete accelerating car? So which one shows an accelerating car? So we have got a distance time graph here, remember. So for a distance time graph, a line like this means no movement. A line like this means we have got constant speed, and constant speed means no acceleration. A line like this means we have got reducing speed. And for reducing speed, meaning we have got reducing acceleration. And then for a line like this, means we have got increasing speed. Increasing speed means we have got increasing acceleration. So therefore, the answer is going to be B for this one. Okay, we've got another one here.